Hello. So we are continuing with the systems of equations. In 5.4, we're going to be talking about nonlinear equations in two variables. So again, just like before, if I'm going too fast, feel free to pause and then continue at your own pace. And if you've got any questions at any point, please don't hesitate to ask. So, systems of nonlinear equations and their solutions. A system of two nonlinear equations in two variables, also called a nonlinear system, contains at least one equation that cannot be expressed in the form ax plus by equals c. So, if it's two variables, one of them can be in this form, the other one cannot. A solution of a nonlinear system in two variables is an ordered pair of real numbers that satisfies both equations in the system. The solution set of the system is the set of all such ordered pairs. As with linear systems in two variables, the solution of a nonlinear system, if there is one, corresponds to the intersection points of the graphs of the equations in the system. So just like it says in the linear system with two variables. Okay, let's look at an example here. So we are solving a nonlinear system by the substitution method, and you can see that it is nonlinear because of the x squared. So that equation is nonlinear. The other one, 4x minus y equals -1, is a linear equation. So our step one is just like we've done with the linear equation. So I'll solve either of the equations for one variable in terms of the other. Now, I'm looking at the top one here. X squared equals y minus 1. What I want to do is I actually, even though the x is kind of isolated and we could take a square root, but that gets a little bit too complicated. So what we want to do is solve this for y. So I'm going to go ahead and add 1 to both sides. So we get x squared plus 1 equals y. So now we have y equals x squared plus 1. What we're going to do now is we're going to substitute the expression from step 1 into the other equation. So we're going to take the second equation here, 4x minus y equals -1. And instead of the y, we are going to write the x squared plus 1. That equals -1. Next, we're going to solve the resulting equation containing one variable. So this one with the x. So we're distributing the negative. So 4x minus x squared minus 1 equals -1. We want to add 1 to both sides so that we're moving the one from the right to the left. Well, they actually cancel each other out. So we get 4x minus x squared equals 0. We're going to take out the greatest common factor here, x, and what we have left, I'm actually going to flip this over, -x squared plus 4x, because it's a little bit easier to have it in that form. So I'm going to go ahead and take out an x. I have -x plus 4 left as the other factor. So x equals 0, or -x plus 4 equals 0, which means that x equals 4. Next, step number 4 is back substitute the obtained value into one of the original equations. And now notice that we've got 2. So we have x equals 0 and we have x equals 4 into the original equation. So we're going to go ahead and take the first original equation here, x squared equals y minus 1. And we're going to plug in x equals 0. So 0 squared equals y minus 1. Well, our y is going to be 1. So 0, 1. Then we're going to take x equals 4 and plug it in as well. 4 squared equals y minus 1. So 16 equals y minus 1. We add 1 and we get y equals 17. So 4, 4, and 17. So our solution set for this is 0, 1, and 4, 17. Both of those ordered pairs. Okay, next one, we're gonna solve a nonlinear system by addition method. We have the system right here. Now it's asking us to rewrite both equations in the form. Well, they already are in the form ax squared plus by squared plus c. We don't need to rewrite it. I'm actually going to go ahead and rewrite them over here in step 2. Because over here, we need to multiply either equation or both equations by appropriate numbers so that the sum of the x coefficients or the sum of the y coefficients equals 0. And now, looking at this, we're going to have to multiply both. I'm going to, if I can, I pick the smallest numbers. And what I'm going to do now is I'm going to go ahead and multiply the top one by -3 and multiply the bottom one by 2. Now, again, it really doesn't matter if I multiplied the bottom one by -2 or multiplied the top one by 3. There are several different ways of doing this and getting the correct answer. The reason why I'm multiplying the top one by -3 and the bottom one by 2 is I am trying to eliminate the y squared. So I'm basically multiplying the first one, oops, that was not what I meant to do. 2y squared. Okay. The first one by the coefficient of the second equation, the y coefficient of the y squared in the second equation, and then multiplying the second one by the coefficient of the y squared from the first one. One of them has to be a negative and one of them has to be a positive to cancel out. So we get, when we're multiplying the whole thing by -3, we get -9x squared minus 6y squared equals -105. The bottom one, 8x squared plus, 6y squared equals 96. And here we go. Canceling these two, minus x squared equals -9. Okay, we can divide both by -1, so we get x squared equals 9. We're actually doing step 3 already. Add the equations and solve for the remaining variable. Now we're going to take the square root and add positive and negative, so x equals positive and -3. Then we're going to back substitute and find the values for the other variable. Now it really doesn't matter which one we pick. I'm just going to go ahead and take the first one. So 3x squared plus 2y squared equals 35. And plugging in, now we did get x equals positive and -3. Yes, normally I would say that, okay, we need to check both, but here's the thing. If we think about x squared, that is going to be 9, right? This does not have a positive and negative. So what I can do is I have an x squared. I can just plug in the 9 over here. Plus 2y squared equals 35. 27 plus 2y squared equals 35. We subtract by 27 and we get 2y squared equals 8. Divide by 2 and y squared equals 4. Take a square root, positive and negative, and we get y equals positive and negative 2. Now, we have 4 different ordered pairs. So you've got to be careful. Both x and y are squared. So our ordered pair, the first one is -3, -2. Second one is -3 and +2. Third is -2. Hold on. No, not -2. X is 3. +3 and -2. And +3 and +2. This is our solution. So because it's x squared and y squared, we have 4 different ordered pairs. All right, let's look at an application here. So find the length and width of a rectangle whose perimeter is 20 feet and whose area is 1 square feet. So use variables to represent unknown quantities. We're just going to say that x equals length and y equals width. Okay, so let's look at a rectangle, x, x, y, and y. Now, write a system of equations modeling the problem's question. So perimeter is 20 feet. If we think about perimeter, we are walking around it. The formula for perimeter is 2x plus 2y. That equals 20. X plus y plus x plus y is the same thing as 2x plus 2y. Area is 21. Area we calculate by length times width, and that equals 21. So there's our system of equations. Now we're going to solve the system and answer the problem's questions. So I'm going to take this second equation here, xy equals 21, and divide by x. So I get y equals 21 divided by x. And now I'm going to go ahead and plug it in the first one. So 2x plus 2 times 21 over x instead of the y equals 20. And now I'm going to go ahead and do 2 times 21 is 42 over x equals 20. Now, to get rid of this x on the denominator, we're going to multiply this by x, and we're going to multiply then the other side by x so that we're not changing it. We're distributing 2x squared plus the x's cancel each other out or become a 1. 42 equals 20x. So 2x squared minus 20x plus 42 equals 0. Okay, so what do we need to do? Minus 20x plus 42 equals 0. We can take out the greatest common factor, which is 2. And now factor this out to x minus 3 and x minus 7 equals 0. So x minus 3 equals 0 or x minus 7 equals 0. So we've got x equals 3 or x equals 7. Now we need to go back and calculate our y. Y equals 21 divided by 3. So y equals 7. Or y equals 21 divided by 7. So y equals 3. So our options here are 3, 7, and 7 and 3. Okay, so that would be our answer. Next, it's asking us to check it. So we're going to start with length x is 3, and width y is 7. We're plugging it in the first one. 2 times 3 plus 2 times 7 equals 20. So 6 plus 14 is 20 equals 20, and that is true. We're going to do it for the second equation as well. 3 times 7 should be 21. So 21 equals 21. That is correct. Now, remember this was this first one. Now we're going to go ahead and take the second one where our length x is 7 and width y is 3. So our first one is going to be 2 times 7 plus 2 times 3 equals 20. Well, yes, that is 20, so that is correct. And then our area is going to be 7 times 3, which is 21, so yes, that is 21. There we go. That's it for this lesson. Let me know if you've got any questions. Bye.